Science, but especially mathematics, plays a major role in our life. Not only dealing with numbers and many equations, but they help us to do our daily life. Mathematics are around us. People think that mathematics only do with related numbers, but in the fact, it's beyond. Galileo defined mathematics as a language in which God has written in the world. These quotes prove mathematics has a great power by its existence.
New York Times reported that the hands of trigonometry has been discovered in a 3,700 years old tablet by Babylonian. This means that our ancient human being has known mathematics since a long time ago.
A mysterious tablet for almost 100 years ago was discovered by American archaeologists in Iraq. Many researchers believe that this tablet is one of the oldest trigonometric tablets used by the ancient world. This tablet called Pimpton 322, as the tablet later bought by George Arthur Pimpton in 1922. The New South Wales University researched this discovery, and they come with a conclusion that ancient world, especially Babylonian, used this tablet to help them find ratios, not angles as we use it now.
To an article posted by New York Times titled How the Father of Computer Science Decoded Nature's Mysterious Patterns by Joanna Klein, we can see how mathematics have developed greatly in the 20th century until now. The article is mainly about how Alan Turing, a mathematician and logician who contributed greatly in the World War II by decrypting the enemy's code and invented modern computing in 1935. Succeeded in decoding the patterns we can find in nature. Unfortunately, other mathematicians believe that his work is yet to be finished, because he died in 1952, making his final work unable to fully display the depth of his thought.
Turing has successfully decoded nature's patterns, and even though a lot of scientists think that his work is unable to fully display the depth of his logic on its matter, it is actually incredible enough that it can inspire a lot of scientists in the present time. Turing's work was able to help researchers solve a lot of world problems. For example, in China they were having trouble with water because they don't have enough clean water for drinking and irrigation in arid places. So, Chinese engineers used Turing's explanation of pattern generation in the research to establish a more efficient water desalination process. Chinese researchers are now able to elaborate how shapes emerge in salt filtering membranes by learning the Turing instability. Furthermore, by creating three-dimensional Turing patterns such as bubbles and tubes in membranes, they have successfully increased the permeability, creating filters that can divide salt from water more effectively by lowering the energy and cost needed in the process of water desalination.
Identifying tsunami from a small X and Y shapes are now the proof that mathematics can predict something big that could happen next.
Scientists have worked out new mathematical formula that could be used to give advance warning of where a tsunami is likely to hit and how it will be.
They solve this correlation with an equation. They predict that oceans can sometimes interact to yield triples that are much taller than the simply added combined height of that originating waves, a sign of what researchers call nonlinear interactions. If they're linear, the wave heights would simply add together. The research shows that the number of peaks and troughs in the initial disturbance out at sea will dictate the number of wave fronts that will stiffen and eventually produce tsunami waves.
Professor Johnson said that by calculating the number of waves that will coalesce or join together as the faster ones catch up the slower ones, it is possible to predict how many and how big and fast the final waves hitting the shoreline will be.
However, using mathematical models to predict natural disasters like tsunami waves could be able to save human lives.
In Origami, Mathematics Increasing by Len Manuel discussed that origami have been discovering the mathematical rules that govern how paper folding works. Mathematics is about understanding the pattern or the rule of the universe. And for origami art, we need to look at the geometry of the crease pattern, where the lines intersect, what angles they form, and in what direction the creases, until we could be able to fold into the object that we want to make.
In 1970s, Japanese astrophysicist Koichiro Miura invented a technique to folding into a tessellation origami. Tessellation origami is where one shape is repeated over and over with no gaps across the whole surface. And this technique is used for deploy large solar panel into outer space. None of this application will be possible without understanding mathematical rules behind origami. And it is a great example of how mathematics and origami can be found in unexpected places.